one go.
All right, so we're continuing from question 17. The pie chart below shows the categories of waste collected from Jamaican households. So we have textile, glass, metals, wood and grass clippings, solid plastic, plastic bag, food waste. So the question is, the National Solid Waste Management Authority, the NSWMA, has suggested that portions of the waste that can decompose should be composted. What percentage of the waste should be composted? Use the data in the graph and recheck your calculations. The National Solid Waste Management Authority, NSWMA, has suggested that portions of the waste that can decompose should be composted. What percentage of the waste should be composted? Is it A, 16%, B, 37%, C, 53%, or D, 47%? So A, 16%, B, 37%, C, 53%, or D, 47%. So have a look at the pie chart. What percentage of the waste should be composted?
Miss food waste.
So they're saying the waste that can decompose should be composted. So look at all those different types of waste and the ones that can decompose.
Miss what is textile?
Textile is cloth, material that you use to make clothes or furniture or stuff like that.
Miss, may I see the options again, please?
Miss, I know that I know that grass clippings can compose, but does wood compose?
16%, 37%, 53%, 47%.
Well, Miss, can I see an answer?
Miss 37%.
So the 37% are, so is it the wood and grass clippings you're saying?
Yes,
Can
miss.
wood decompose?
Yes, wood decomposes. It's a natural fiber. Madison,
Miss,
what answer are you giving?
Miss, I have 53.
How did you get 53?
Because the food waste and the wood and grass clippings can decompose. So 37 plus 16 is 53.
That is correct. So the metals won't decompose, the glass. Some textile will decompose, but like cotton or burlap or those natural fibers, but it doesn't say.
Miss, I also got 53 for number 17.
Right. And 53 is the biggest. So we wouldn't be adding textile to that. Plastic definitely cannot decompose. So the answer is 53%. Item 18, also quantitative reasoning, category data analysis, targeted skills, analyze and interpret data, draw conclusions. Jaden, can you read question 18, please?
Okay, Miss. Question 18. A student conducted an investigation on the effect of fertilizer on the height of red peas, grown over a period of 4 weeks. The student's results were placed on the chart below. Question 18. A student conducted an investigation on the effect on fertilizer on the height of red peas grown over a period of 4 weeks. The student's results were placed on the chart below. effects on of fertilizer on plant height
Okay.
of plant in centimeters.
All right.
Okay.
So the height of plant is on the vertical axis, the amount of fertilizer on the horizontal axis. So look at the pattern of how the plants are growing, depending on the amount of fertilizer given, how high the plants grow. Right? So just take a minute and study that. So when it's no fertilizer, this is how high it grows. 5 grams of fertilizer, that's how high it grows, and so on. So look at each statement carefully. Is the statement supported by the graph? All right, Madison, read the statements for me. Read everything on this slide for me.
Okay. Choose the letter to show whether the following statements are supported or not supported based on the results of the investigation. Statements. 1. Plant height is not affected by the amount of fertilizer. 2. Increasing the amount of fertilizer will always increase the plant height. 3. Fertilizer amounts over 25 grams will reduce plant growth. Choose the letter to show whether the following statements are supported or not supported based on the results of the investigation. Statements. 1. Plant height is not affected by the amount of fertilizer. 2. Increasing the amount of fertilizer will always increase plant height. 3. Fertilizer amounts over 25 grams will reduce plant height.
All right, so let's examine the first statement. Plant height is not affected by the amount of fertilizer.
Not
Is
supported,
that
miss.
true?
Not
Definitely
supported.
not supported.
It's not supported because we see clearly that the height of the plant is affected by how much fertilizer is given. So that one is not supported. How about 2? Increasing the amount of fertilizer will always increase the plant height.
Miss, not
That is
supported.
not supported.
That's
Not
not
supported.
supported because here we have more fertilizer, but it starts to diminish. You see that? So
Decreasing.
right. So
Yes,
it
miss.
reaches
After 25.
a height at 25 grams. That's the maximum height. When you increase the grams, after that, the plant starts shrinking. It doesn't grow as well. So that one is not supported either. How about 3? Fertilizer amounts over 25 grams will
Miss
reduce
supported.
plant growth.
Miss
Miss
A
supported.
supported.
Right, that's supported. So once it
It's
passes
supported.
25, yes, once it passes 25 grams, the plant growth stops and it starts to diminish. So that one is supported. Item 19, quantitative reasoning, data analysis patterns as category, targeted skills to analyze and interpret data and to predict. All right, Lejande, please read question 19.
Question 19. The body temperatures of different animals in hot and cold environments are shown in the table below. Table showing body temperatures of animal in different environments. Name of animal: snake, bobcat, fish, rat. Animal body temperature, cold environment, 10 Celsius.
10 degrees Celsius.
10 degrees Celsius, sorry. Snake, 10. Bobcat, 38. Fish, 10. Rat, 38. Hot environment, 30 degrees Celsius. Snake, 30. Bobcat, 39. Fish, 30. Rat, 38.
All right, read it again, please, Lejande.
Question 19. The body temperatures of different animals in hot and cold environments are shown in the table below. Table showing body temperatures of animals in different environments. Name of animal: snake, bobcat, fish, and rat. Animal body temperature, degrees Celsius. Cold environment, 10 degrees Celsius. Snake, 10. Bobcat, 38. Fish, 10. Rat, 38. Hot environment, 30 degrees Celsius. Snake, 30. Bobcat, 39. Fish, 30. Rat, 38. And Miss, I just want to put out one thing. The snake, the fish, the rat, in the cold and hot environment, they're not the same number, but like in the columns with the 10 and 10, they're the same number. The 30 and 30, the same number. The 38 and 38 are the same number, except for the bobcat. Bobcat has 38 and 39.
All right. So in the cold environment is 10 degrees Celsius. The snake and the fish have the same temperature as the environment. Do you see that? Right. So they have the same temperature as the environment. The bobcat and the rat, they have different temperatures than the environment. And in the hot environment, again, the snake and the fish have the same temperature as the environment. So they adjust their temperature according to the environment. The bobcat and the rat still maintain pretty much their regular body temperature, just varying by 1 degree for the bobcat. So what can we deduce from this? How do the animals adjust their temperature?
Okay, miss for the rat, miss, it's both 38 in the cold environment, miss, and the hot environment. So, miss, it doesn't change its temperature, miss. It just stays the same in either
Right.
in the either cold and hot environment.
Right.
miss,
And that's what kind of animals are they? What group of animals they fall under?
Miss,
the rat
the
is a rodent.
It's a rodent, but what's the bigger group they fall
Miss,
under?
both the bobcat and the rat are both mammals,
They are mammals, right? And mammals are warm-blooded.
meaning that they can
Mammals,
adjust their temperature.
yes, mammals are warm-blooded and they have homeostasis and they try to maintain a constant body temperature no matter what environment they're in. They try to maintain a constant body temperature. Some other animals like amphibians and fish and reptiles, some of them, they adjust their body temperature to suit their environment. And we see this with the snake. So the snake, in just like the cold environment, when it goes in the hot environment, it is 30. And likewise for the fish, it's 10, just as how the cold environment is 10. And when it goes into the hot environment, it adjusts. So the question is, John, can you read that question for me?
Okay, miss. A student placed a snake and a rat in an environment at 25 degrees. Which body temperatures are they most likely to have after a few days? A. Snake 20 degrees and rat 25 degrees. B. Snake 25 degrees Celsius and rat 38 degrees Celsius. C. Snake 37 degrees Celsius and rat 25 degrees Celsius. D. Snake 38 degrees Celsius and rat 38 degrees Celsius. A. A student placed a snake and rat in an environment at 25 degrees. Which body temperatures are they most likely to have after a few days? A. Snake 20 degrees Celsius and rat 25 degrees Celsius. B. Snake 25 degrees Celsius and rat 38 degrees Celsius. C. Snake 37 degrees Celsius and rat 25 degrees Celsius. D. Snake 38 degrees Celsius and rat 38 degrees Celsius. Miss, the answer would be B. Snake, 25 degrees Celsius and not 38 degrees Celsius.
Okay, and why do you say that, John?
Well, Miss, in the table, Miss, it showed that even in a cold or hot environment, Miss, the snake will just adapt to the temperature, Miss, and stay at that
Okay.
temperature, and the rat would stay at 38 degrees.
Okay, so that's correct. So the snake would adjust to the 25 degrees of its environment, while the rat will try to maintain its body temperature of 38
Oh, Miss, I
degrees.
have something to say.
Go
Miss
ahead.
already did this paper. Miss already did this paper.
Okay, good for you, John. All right, item number 20. Item type, quantitative reasoning, category data analysis, targeted skills to analyze and interpret data and to draw conclusions. All right, Madison, back to you. Question 20.
Question 20. A student measured the time it takes for water to pass through different soil samples. The diagram of the experiment is shown below. The table shows the results of the student's investigation. Question 20. A student measured the time it takes for water to pass through different soil samples. The diagram of the experiment is shown below. The table shows the results of the student's investigation.
Okay. So let me go to the question. All right, so this is the table showing the volume of water and the time taken for different soils. Time taken for the water to pass through different soils. So the volume of water added to soil in centimeter cube was 30. So each soil type, the clay, the loam, and the sand, 30 centimeter cube of water was added. And the volume of water collected in the cylinder, for the clay, it was 24 centimeter cube. For the loam, 27 centimeters cube. And for the sand, 29 centimeters cube. The time for the water to pass through the funnel in minutes. 5 minutes for the clay, 2 minutes for the loam, 1 minute for the sand. Choose the letter that completes the conclusion below. Water takes longer to pass through A, clay, B, loam, C, sand, soil. Clay, loam, or sand soil has the least water holding capacity of the soil samples. Lejande, can you read this question again, please, from the top?
Okay, miss. Table showing the volume of water and time taken for different soils. Volume of water added to soil, centimeters cubed. Volume of water collected in cylinder, centimeters cubed. Time for water to pass through funnel, minutes. Volume of water added to soil, clay, 30, loam, 30, sand, 30. Volume of water collected in cylinder, clay, 24, loam, 27, sand, 29. Time for water to pass through funnel, clay, 5, loam, 2, sand, 1. Choose the letter that completes the conclusion below. Water takes longer to pass through A, clay, B, loam, C, sand, soil. A, clay. Soil has the least water holding capacity of the soil samples. B, loam soil has the least water holding capacity of the soil samples. C, sand soil has the least water holding capacity of the soil samples?
All right, so based on this table, clay, loam, and sand, the three soil types, 30 centimeter cube of water was poured over the three soil types. At the end of the experiment, after a certain number of minutes, this amount of water was collected under in the cylinder. So the clay soil took 5 minutes for the 24 centimeter cube of water to collect. The loam soil, after 2 minutes, 27 centimeters cube was collected. And for the sand, after 1 minute, 29. So almost all the water passed through the sand in 1 minute. So
Miss, can I
so
answer
what
that?
took longer to pass through which soil?
Miss, the
A.
clay soil.
It's
Clay.
A. Clay.
Correct. So we all agree it takes longer to pass through the clay. It took 5 minutes, and even then, not all the water had come back out. You see that? 6
Yes,
centimeter
Miss.
cube of it. And which soil has the least water holding capacity?
Miss Sand.
Miss the
Sand.
sand.
Correct.
Sea sand.
Because within 1 minute, almost all the water has passed through the sand. So it has the least water holding capacity. We're to analyze the results in the table, which soil held the most water. So clay held the most water, and how quickly did water pass through each soil? All right, so that was given in the table, right? So 5 minutes for the clay, 2 minutes for the loam, and 1 minute for the sand. Item 21, quantitative reasoning, category patterns, data analysis, targeted skills, analyze and interpret data, and identify patterns. All right, so what I'm going to do now is to allow some other scholars to come on. All right, so I have 2 scholars waiting backstage. All right, so I'm going to ask John and Amari to wait backstage for a little bit, and Legion Day to wait backstage for a little bit. And I'm going to welcome Rodriguez and Shalicia. And those who are backstage, you can still post your comments and your answers, and I'll read them. Welcome, Shalicia. Welcome, Rodriguez. Welcome, scholars. Good evening. Are your mics working?
Yes, miss.
Oh, so I said good evening. Okay, it doesn't seem as if your mics are working. All right, so let's continue. Question 21. Jaden, can you read question 21, please?
Okay, miss. Question 21. Number 20. A student wants to find out how the temperature of the water affects the time it takes for a sugar cube to dissolve in water. He does the experiment 3 times at 4 different temperatures. He uses 1 sugar cube each time and the same volume of water. The results are shown in the table. Question 21. A student wants to find out how the temperature of the water affects the time it takes for a sugar cube to dissolve in water. He does the experiment 3 times and 4 different temperatures. He uses 1 sugar cube each time and the same volume of water. The results are shown in the table.
All right, so this is the table, and 4 different temperatures were used, 3 different tests, the same amount of sugar each time, the same amount of water each time. So for test 1, at 30 degrees Celsius, this is the time it took for the sugar to dissolve. Test 2, this is the time it took, and test 3, this is the time it took. For 40 degrees Celsius, it took 8 minutes, 8 minutes, 9 minutes. 50 degrees Celsius, 7 minutes, 7 minutes, 8 minutes. And 60 degrees Celsius, 6 minutes, 6 minutes, and 7 minutes. So 3 different tests and 4 different temperatures. And the time was recorded, how long the sugar took to dissolve in the water. Amari, could you read this, the options, please?
Which statement best describes the pattern? The pattern of the results. A. The more water used, the shorter the time taken. B. The higher the temperature, the longer the time taken. C. The more water used, the longer the time taken. D. The higher the temperature, the shorter the time taken. Miss, I say D. The higher the temperature, the shorter.
Please read the options one more time.
A. The more water used, the shorter the time taken. B. The higher the temperature, the longer the time taken. C. The more water used, the longer the time taken. D. The higher the temperature, the shorter the time taken. Miss, I say D. The higher the temperature, the shorter the time taken.
All right, so let's look at that. So you're saying, so when the temperature was 30 degrees, we have 10 minutes, 40 degrees, 8 minutes, 50 degrees, 7 minutes, 60 degrees, 6 minutes. So and this is test 1. So the more the temperature rises, the less time it takes. And the pattern is repeated in test 2. Less time it takes, the more the temperature rises. The pattern is repeated in test 3 as well. So you are correct, Amari. The answer is D. The higher the temperature, the shorter the time taken. It could not be A or C because the water was not varied. The same amount of water was used each time. For item 22, the type is quantitative reasoning, category data analysis, targeted skills to analyze and interpret data and to draw conclusions. All right, John, question 22.
Okay, Miss. I'm question 22.
Excuse me, miss.
Yes,
Can I get a minute, please?
Yes, go ahead.
Number 22. A class investigated the habitat preferred by woodlice. They set up a choice chamber with 4 sections: W, X, Y, and Z representing the different habitats for the woodlice. Question 22. A class investigated the habitat preferred by woodlice. They set up a choice chamber with 4 sections: W, X, Y, and Z representing different habitats for the woodlice.
All right, Jaden, can you continue that question for me?
The class released 20 woodlice into the chamber and counted how many woodlice were in each section after 5 minutes. These are their results. The class released 20 woodlice into the chamber and counted how many woodlice were in each section after 5 minutes. These are their results. Sections Y, X, W, X, Y, Z. Description. W, dry and light. Number of woodlice, 2. X, damp and light. Number of woodlice, 5. Y, dry and dark. Number of woodlice, 3. And Z, damp and dark. Number of woodlice, 10.
All right. Before I go any further, let me acknowledge the answers in the chat. As you know, the chat sometimes lags behind, so the answers are coming in late, but I just want to read them for you. So Ashlyn had said, water takes longer to pass through clay soil, and sand soil has the least water holding capacity of the soil samples. Haley also said clay for A, and Rodriguez had said A, clay. All right, so we're going to continue. For question 20, Shalisa is, question 22, Shalisa is saying Z. So let's look at what the question actually is asking. What conclusion can the class make from the results? A, woodlice prefer dark habitats. B, woodlice prefer damp habitats. C, woodlice prefer dry habitats. Or D, woodlice prefer the light. And we're to compare the number of woodlice in each section. What is similar about the sections that had more woodlice? So what conclusion can the class make from the results? A, woodlice prefer dark habitats. B, woodlice prefer damp habitats. C, woodlice prefer dry habitats. D, woodlice prefer the light. And we're to compare the number of woodlice in each section. What is similar about the sections that had more woodlice? So let's see. The sections that had more, which is the 10, Z was damp and dark. 5, damp and light. So
Miss,
the similarity is the dampness, right?
yes, Miss. My answer is B. Woodlice like damp.
Right, so they do love the damp. They do love the dampness. That's what these two had in common. The dryness, just 2 and 3 woodlice. So let's look again. Woodlice prefer dark habitats, damp habitats, dry light. So we're going with the damp, right?
Yes,
Damp
Miss.
habitats. Right. All right, question 23. Quantitative reasoning, data analysis, comparing quantities, and we are expected to be able to analyze and interpret data to compare and to draw conclusions. So analyze the information in the graph. Question 23. A student investigated the strength of different types of paper by hanging different masses on the paper until the paper tears. A student investigated the strength of different types of paper by hanging different masses on the paper until the paper tears. So this is the paper in the experiment, and this is the mass that was hung from the paper, and then the paper, it was left to tear. So the results are shown in the bar graph. The newspaper the tissue paper, printer paper, and writing paper. And on the vertical axis is the number of masses needed to tear the paper, right? So the newspaper, 2 masses needed to tear it. Tissue paper, 1 mass needed to tear it. The printer paper, 3 masses needed to tear it. And the writing paper, 4 masses. Which type of paper was the strongest? Was it A, the printer paper, B, the newspaper, C, the tissue paper, or D, the writing paper? Which type of paper was the strongest? A, printer paper, B, newspaper, C, tissue paper, D, writing paper. All right, what are we saying for these scholars? Do you need to see the bar graph again?
Yes, miss.
All right, so let's go back to the bar graph. So the newspaper, 2 masses.
Miss, my answer is D, writing paper.
All right, Jaden, why do you
Yes,
say the
miss. I
writing
agree
paper
with
was the strongest?
Jaden.
Since writing paper has the largest amount of mass needed to tear it, which is 4.
Okay.
4 number of masses.
So Legende says she agrees. Do we all agree that the heavier the mass needed to tear the paper, then that means that's a stronger paper or the strongest paper? Do we agree? The tissue paper,
Yes, miss.
we know
Yes, miss, I
the
agree.
tissue paper is
Yes,
delicate, right? So 1 mass was needed to tear the tissue paper. All right, so we're agreeing that the writing paper is the strongest of the 4 papers. All right, let me check the time because I'm wondering if we should end this here, and instead of doing the performance task tomorrow, we could do another session of ability test, since the ability test is coming up in a couple weeks. And we have, this is question 23. We have 7 more questions. We started at, so we've roughly covered 8 questions. So I'm thinking we can do the rest of these questions tomorrow as a continuation of the ability test, and just part the performance task just for tomorrow, since the ability test is coming up. What say you guys?
sure, miss.
Okay. All right, because we have like 3 minutes before 8, and I'm scheduled to have a CSEC math class starting at 8. All right, so everybody's agreeing that it's a great idea. Okay. All right, and Cashmark said yes, he got writing paper as the strongest. Boy, the answers in the chat are coming in so late. Haley is saying clay for A. Haley, we passed that like 2 weeks ago. We did that question like 2 weeks ago. All right, so that's what we're going to do. So we're ending at question 23. Tomorrow we'll start at 24 and go up to 30. All right. Yeah, so that's what we're going to do. All right, scholars, thank you for your time and your participation as always. And I'll see you tomorrow. Thank you to those in the chat who also participated, and we encourage you to drop your answers, your questions, your comments, your suggestions. And if you want to join us in studio, just follow the studio link and you can join us and participate from here. So I'll see you scholars tomorrow. Enjoy your night.
Love you, miss. Bye.
Love you too. Have a
Bye,
restful night.
my classmates.
Alright, I'm going to see you in a
Bye.
second.
Oh
Love
my
you too,
God,
Jaden.
See
Ashlyn
you
is counting
tomorrow.
down. Ashlyn says 2 weeks, 6 days, 4 hours, 1 minute until ability test. Oh my God. Shalisa says, love you all. Bye. Ashlyn, you're really counting down, man. 2 weeks, 6 days, 4 hours, 1 minute. Ashlyn is counting down the ability test. Well, the good thing is you are going to be prepared because we have been doing a lot of ability test practice. If you missed those first ability test sessions that we did, just go on the channel, check out the live sessions that we did. We have many ability test sessions that we did. And then once you have that done pat and the ability test has come and gone and you mash it up like mashed potato, then you can check out we have performance tasks sessions, we have the curriculum based tests, we have critical thinking sessions. Just set up your camp, set up your tent and camp out there and just go for the section that you want to study at that time. And there are tons of videos. We have tons and tons of videos. I'm going to play for you now the schedule of live classes so you'll know. So Ashlyn says, and now it's 2 weeks, 6 days, 3 hours, and 58 minutes. This girl is so serious. She is so serious about her ability test. She's counting down the seconds. Here is the schedule of live classes. So tomorrow, Ashlyn will update us as to how many more seconds we have. Hello CSEC math students, I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now in this series we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.